So welcome to my work solutions for the Edexcel Higher. It's the GCSE from January 2020. As you can see, it's the paper 2R. So here we go. First off, just simply combining the powers. Don't forget, when you multiply, you add the powers. So we get 5 to the power of 19. Write as a product of prime factors. Plenty of methods. You can either do repeated bus stop, anything you want really. I just go for the standard. Let's do 80 times 10. The 10 can be 5 2s. And that can be what? Let's go for 16 5s. And that will give us 2 times 2 times 2 times 2. Lots of 2s. Now, it doesn't ask for it in index form, but it's certainly going to save time if we do. So I'd write my answer like that. On to the next one. They haven't done the usual trick of giving you a clue by moving the boxes over to the left. So that's where I'm going to put my midpoints. So halfway in between everything, that'll be 10, 30, 50, 70, and 90. And we grab the calc with a bit of a mental arithmetic, and we do multiplied. So basically it's frequency times x is fx. That's how some people usually like to refer to it. So we get a 50, a 330, a 400, 1, 3, 3, 0, 8, 10. But do notice it doesn't ask for an estimate of the average. So this is not sigma fx over sigma f, or in other words, total divided by total of the frequencies, sigma f. Nope, just wants the total of these. And when you add them up, it's £2,920. And that's it. That's why it's 3 marks, not the usual 4. So, the next one, we've got 3 tins. It's pretty much laying it out for you. And the word total. So tin A contains X. B is 4 times. C is 7 fewer than A. And it's saying the total is 137. We've set it up. Let's simplify and get it solved. So all the x's together give us 6. We add 7 to both sides for 144. And we get that x equals 24. But it's a bit easy to fall into the trap and think that's the right answer. Be careful. It says work out the number of buttons in tin C. X is tin A. So we've got to subtract 7. In we go. Very easy to fall into that trap. Number 4. Length of diagonal. Now, sometimes Pythagoras is quite hidden. This is certainly not. The length of the diagonal is the square root of the 2 shortest sides squared and added. Grab your calc. I get the answer of 10.17-ish. 1 decimal place. Do as you're told. It's 10.2. Next one. The tricky bit here, do not forget, minutes and decimal not the same. So 1 minute is 1/60th of an hour. So yeah, this is a DST question. And it's asking for the average speed. So you need to do distance, 2,470, divided by, time. Now what you can't put in is 3.36 because that's not correct. So the idea is 1 minute is 1/60th of an hour. So 36 minutes is 36/60ths of an hour. And you could put that in your calc. That would be fine. So 36/60ths does cancel down. It is 3/5. Or else you could put 3.6 in your calculator. Either is good, but certainly be aware the minutes and decimals, they aren't the same. When you say see you in a quarter of an hour, it's not 25 minutes, it's 15. Just because a quarter is 0.25, no, not the same. Do not fall into that trap. So on my calc, I get 686.1 recurring, nearest whole number, 686. Next one, done my usual cheating, because there's no way I'm going to even attempt doing this one with an electronic pen. So for some reason, they've decided to put the line on an angle. So you turn your page, you set your compasses to over halfway, metal bit on there, semicircle. Metal bit on there, semicircle, and join the crosses. And obviously worth double checking by eyesight, or if you've got time right at the end of the exam, come back and check it with a protractor. Number 7. Another bog standard one. As easy as it comes, really, because you've got a 5 in front of the Y. So it's just, is it add or is it subtract? And I'm sure your teacher has said, same sign, subtract. Well, these are plus and minus. They're different. So we are going to add. We get 10x on the left-hand side. The Y's cancel out. And 6 added to a debt of 11 minus 5. We divide both sides by 10, so minus a half, or minus 0.5, write your answer there, or here. I do both. Then pick one of the two equations. I'll pick the top one, just because it's got fewer negatives, so I'd say less risk of messing it up. And I replace the x with minus a half. So 3 times minus 0.5 into my calc if I need to. So on my calc, I would do 6, and this is a negative, so I'm going to do 6 plus 3 over 2, or 1.5, and then divide my answer by 5. We get a nice 1.5 for our answer. On to 8, another bog standard. You've got your capital, in this case the value of a car. Depreciation means 19% off your 100, so it's 81%. So you multiply, you could write either as 81 over 100. I always prefer decimals. And it's 3 years. It's power of 3. My calculator spits out 10,628. It wants nearest dollar, so as always, do as you're told. 10, 6, 2, 9. Number 9. Be careful on this one. You'll notice right at the end, it doesn't specify centimetres or metres. And you have a problem that the measurements are in centimetres. But then it goes on and says the face of the box has length 1.2 metres. So I've got to admit, I've looked on the mark scheme. It's not massively clear. I actually think this is a bit of a mistake. So as long as you're clear what's going on, it's fine. So the way I went about this is I wanted to stick with meters, so I simply changed. So 1 centimetre is 0.01. So that's 0.012 meters. So it says work out the value of x. X is linked to the area. So that's where the area goes in. So we can say that the area is the force, which is 27, because we basically just flip them around. So area is force divided by pressure. And because it's newtons and newtons per meters squared, our answer is in meters squared. And so my idea is that length times width, so length in centimetres times width is what, 0.012, gives us 0.9. Alright, so you divide both sides by 0.012 and you get x to be 75. So applying a bit of common sense, that means we're talking 75 centimetres, or if you wanted to, 0.75 metres. But worth being clear on there. I think that's a slight grey area on their behalf, I must admit. So it's up to you to be clear. Number 10. It says work out the difference. That means subtract. Biggest take away smallest, so we do Atlantic. Take away Indian. Calculator says 37,400,000. Your job is to put it in standard form, so 3.74. And you could count the loops, or you could remember that million is power of 6, so tens of millions should be power of 7. Part B, the surface area of Pacific is k times. So it's like me saying, what do I multiply 2 by to get 8? Well, obviously it's 4, but you could work that out by doing 8 divided by 2. You work out a multiplier by dividing. So it's 1.156 times 10 to the 8 divided by 1.41 times 10 to the 7. Get all that in your calculator. Brackets if you need to, if you've got one of them that's a little bit fiddly, but make sure you get 11.06-ish. We're told for nearest whole number. We've got 11. Number 11. Write down the integer values. It's always a big list. So what integers could x be? Well, it can't be as low as -2. So the lowest it can be is -1. And we write them all down. No shortcuts. But we can go as high as 4. Job done. Next one, inequalities, but they're drawn for us, they're given for us. You just need to work out where the inequality goes. So I will do the easy ones first. Let's do the horizontal line. So we need to be below that line. So we can say that the height, in other words, y, must be underneath or equal to 6. The next one, we've got x plus y, and we're working that side. So over here, x plus y would be like 7, 8, 9, 10. X plus y greater than or equal to 5. And we've got the final one of y equals x minus 3. So always remember that y equals the height. Y is how high it is, and we want to be above that line. So vertically, we want the y to be greater than x minus 3. Usual mark scheme of I think it's get 1 right, get 1 mark, got to get all 3 right for 2 marks. Number 12, bit of knowledge, don't forget about internal angles, alright, in terms of you subtract 2 times 180 and all that malarkey. So first of all, equilateral triangle, doesn't say give reasons, so we can just insert that this angle here, the internal angle 66 plus 66 is 132. So that little fella there is 48. So if that's 48, these angles around a point make 360. And because x and y are congruent, in other words, they are identical shape, size, particularly in this case angles, then we need to do 360 minus the 48 we know, and the angle above and below are going to be the same. So we divide it by 2. So the internal angle is 156, which makes internal and external angles make a straight line. So if that's the external angle, the internal angle is 24, and we're pretty much there, because how do you find, if you work it backwards, how do you find I've got them wrong around, sorry. Hey, don't shout. Externals 24, my mistake. If you do 360 divided by the number of sides, you get the external angle. In this case, 24. So you can times both sides by n, divide both sides by 24. You get the number of sides to be 15. Apologies, got a bit mixed up there. Number 13, they've given you loads of room for this. I don't get it. It says prism. So the formula for the volume of a prism is area of the face multiplied by its third dimension, in this case 10. So we can make the statement that the volume of 608 is equal to the average of the parallel sides. So 7 plus 12 is 19 halved. And it's the average of them multiplied by the distance between them. That gives you the area of the trapezium. That's then multiplied by the third dimension. And that is a correct statement. Our job is to find h. So grabbing your calculator, stick in 608, divide both sides by 10, multiply both sides by 2, divide both sides by 19, and you're getting your value of h. So 608 over 95, but 6.4 looks a lot more friendly and certainly tidier. Number 14, this is a pain because, as you can probably tell from Year 7 mean, median, mode and range, yeah, you've got to put them in order first. So 5, 7, 11, 12, 13, 14, 15, 16, 17, 18, and to catch you out, there's no 19, there's another 18. So there's 11. So you add 1 to make 12. So if you wanted the median, you would find the middle value. That would be the 6th number. We don't. We want a quarter of 12. That's the 3rd number. And treble of a 3rd is 9th. There's our 9th number. Subtracting these gives you your interquartile range. As always, cheated on these. I've plotted it already. Use your calculator when you're subbing them in. Usually you get lots of symmetry, but that x over 2, you'll notice on the diagram, you don't get symmetry. You get symmetry in the graph, but not in the coordinates you're finding. So unfortunately, no shortcut. You can grab your calculator or make some jottings, whatever works for you. When you sub in 2, we get 0. When you sub in 0, you get -3. These two are the trickiest ones. If you're going to use your calc, make sure you're careful with the brackets, because when you square a negative, it becomes positive. And if you're going to use your head, don't forget when you sub in -2, that's quite tricky. -2 squared minus -2. So that becomes positive, etc. So lots of hurdles in this one. Not as straightforward. One of the harder kinds of plotting quadratics. Once you've got them, I made a right bodge, had a right wobble at the bottom, but no worries. Smoothish curve. Hopefully yours is better than mine. Number 16, good old probability trees. I don't even bother reading the waffle. Always fill in the obvious first and then say to yourself, where does it tell us bag B? There are 12 counters, 7 are odd. 7 over 12, 5 over 12, 7 over 12, 5 over 12. What's the point in reading all that waffle? And then it asks us, I'll stay on this page. Part B says, calculate the probability that the total of the two numbers will be odd. So total means you are adding them. So odd plus odd will give us an even. So that's one we want. Even plus even will give us an even. So that's also what we want. So with probability trees, we're going to do top fraction times top fraction added to bottom fraction times bottom fraction, which will look like this: 7/10, 5/12 added to 3/10, 7/12. In your calc will work it all out. Just cancel it. Obviously 56 over 120 is okay, but your calc will cancel it down to 7/15. Now the final part, bit of a strange one. Waffle, 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 yeah. But Harriet's, the probability, here's where it gets important, the probability that the number on each of Cody's two counters and the number on Harriet's counter will all be even is 3 over 100. So let's wind that back. Let's look at Cody's counters. Even, even. That's bottom, bottom. So Cody even is 3/10. Cody even bag B is 5/12. Harriet's we don't know, but we know it's equal to 3/100. So it's a divide question. On your calculator, 3 over 100 or 0.03, divide it by 15 over 120. You get x equaling 6 over 25. So she must have at least 25 counters. There could be 50 counters, but it asks for the least number. Could be 50, could be 75 or 100. Can't be any lower because we can't have a decimal number of counters. On we go. Number 17. Dog, cat, rabbit. Interesting thing for me. Rather than reading top to bottom, it's usually easier to read bottom to top. Here's why. So 5 have not got anything. Done. Because when you read 28 have a dog, that means the total is what you have to carry on to find information. And normally details don't come until the end, so I like to do these backwards. Next, 6 have a dog, a cat, and a rabbit. So in other words, 6 have all three. X have both a dog and a cat. I'll come back to that. 9 have both a dog and a rabbit. So there's dog, there's rabbit. 6 we already know about. So it's 3 in there. That will make the total of 9. 8 have both a cat and a rabbit. So the intersection needs to total 8. So it's 6 plus 2. It then says 20 have a rabbit. Nice one, because we've already got 3 bits of the information. We just subtract them all from 20. 18 have a cat. I'll just park that for a sec. 28 have a dog. I'll just park that for a sec. Let's go back to this X. So X have both a dog and a cat. We already know about 6 of them. The total of the intersection must equal X. So the only way that can be possible is if this number, in inverted commas, if this number there is X minus 6. Now I can move over to the 28. If I knew what X was, I'd find this number out by doing 28 minus everything. Well, just because it's got an X in there shouldn't stop you. 28, take away 3, take away 6, means I'm down to 19, but then take away minus 6, I'm up to 25, then take away X. Similar approach to the cats. So cats, 18 in total, take away 6, take away 2, I'm down to 10, but then take away minus 6, I actually go up, and then take away x. And for part B, given that the total is 50, so your job is to add everything up. So let's do the x's first. We've got a negative, negative, positive. That's a negative 1x in total. We've got, if you add up all the numbers, you get plus 60. And we're told it should equal 50. Looks weird, but it's not that bad. Adding x to both sides, taking away 50 from both sides. It all works out pretty nice in the end. And for part, there's a little part C on the end. So it says find the number that are in not C intersection not D. So the idea of that is not C is get rid of them. Not D is get rid of them. It's what's left. So as you can see, there's only two numbers left. 9 and 5. 14 people fall into that. Strange little question there to tack on the end. Number 18. Some teachers like to set these out as divides. I prefer to just multiply. I'm just going to say that the unknown, PD, is x. So as we know, they end up multiplying to give the same answer. So you can say that 9 times 6, the product of that chord there, the product of the length of the two parts of that chord, equal the product of those two parts, 8 times x. So you do 54 divided by 8, 6.75. I mean, seriously? Number 19, algebraic fractions. Some people prefer to get things by multiplying by 5, then multiply by 2. I like to just get it all done in one. I'm going to times everything by 10. So this first term, the 5's cancel out. I just need to double the top. Second term, the 2's cancel out. I just need to multiply the top by 5, but being careful, there's a minus 1 in front. So it should be negative 3x times 5. And it should be negative 5. So positive 5 times 5. And equals negative 3 times 10. Let's get like terms collected. So minus 21x. While also subtract 8 and subtract 25 from both sides. Divide both sides by minus 21. Turned out nice. Part B. So job 1, make it, I would say, equal to 0, but doesn't matter if you use x's, but let's stick with, doesn't matter if you use x's, like I say. Whoops, we need a 40. Your choice. It's certainly not one I would be completing the square on. Feel free to go for the formula, for the quadratic, for your critical values, not solutions, by the way. But because I've already had a bash at this, I've already used the AC method. It's 5y plus 8 and y minus 5. So, on a number line, it's a positive y squared. So if you were graphing it, it would look like that. And the solutions would be positive 5 and negative 8 over 5. And this is saying to you, where is this graph below 0? And it's below 0 between those answers. Minus, I'll write it as 1.6 and 5. Number 20. They do love these linear, area, and volume scale factors. Seem to really love them. Going from small to big or big to small depends on how you want to think about it. I'm saying that in terms of height, the linear scale factor is 13 over 9, because 9 times 13 over 9 is 13. So if we were doing the same in area, it means the length would multiply by 13 over 9, and the width, or any two dimensions you want to name them. The fact is the area scale factor is the linear scale factor squared. So we don't know what the surface area is. So I'm just going to say that the surface area of A is A. And if I multiplied by the area scale factor, I get the surface area of B. Well, I can. I can indeed multiply A by the area scale factor. And that is equal to 1,800. And it is just a solve question. Loads of ways of going about this one. I'm going to do it fancy. I'm going to take an A out. That'll give me 1 plus 169 over 81. And say to you that the surface area A is equal to 1,800 divided by all that nonsense. And if you stick it all in your calculator, we get 583.2, which, believe it or not, is correct. Number 21, more factorising. Feel free to use the AC method if you want, but the fact that on the top they're all positive makes it reasonably doable in term. If you want to do the AC method and call it 120, two numbers that multiply to make 120 and add together to make 23, etc. But I actually did this one by sight, not wanting to brag. But there is also the clue that on the bottom there is the difference of two squares. 4x squared square rooted is 2x. 9 square rooted al is 3. And that gives you a massive clue that when you were factorising the top, the numerator, it had to have a 2x in it, which meant if it has to have a 2x, it has to have a 5x. So that eliminates the possibility of 10 and 1. But however you've factorised it, those two cancel out, and we're left with 5x plus 4 all over 2x minus 3. Part B, strange laws of indices. So on the left-hand side, we can simplify them straight away. When you multiply them, you've got 2y there, 3y plus 2. Multiplying means add the powers. Not so straightforward on the right-hand side because 8 and 4 are different numbers. But hold on. 8 is 2 cubed. And to save room, I'm going to write it as a divide like that. 4 is 2 squared. So, as you can see, we've now got laws of indices. Power to a power means multiply the powers. 3 times 5y, 2 times n. And that's the same thing over here. We haven't touched it. And there we go, really. Because the 2's, the base numbers, whatever you want to call them, they are the same. So we can make the statement that the powers must be identical. So the power on the left is 5y plus 2, and the power on the right, divide means subtract, is 15y minus n. Sorry, the power is 2 to the 2n now. Having a good day, folks. And it says find an expression for n in terms of y. They want n equals. So I'm going to add 2n to both sides. I'm going to subtract 5y from both sides and subtract 2 before finally halving everything. 5y minus 1. Job done. Number 22. Always at this point look up on your mark scheme, on your formula page. The first term is minus 6. Write it down. Sum to 30. There's a formula for that. Go and look it up. It says n over 2 into 2 lots of A plus n minus 1 lots of D. And that, I'll squeeze in, is 2865, just about. Now you can't start doing that until you've worked out D. So let's carry on. Let's divide both sides by 15. Let's get the numbers a bit more manageable. 191. And now it's a case of solving. So you grab your calc, you do 191, you add 12 before dividing that answer by 29. You've got your D. We can move on to the final phase. The 9th term is the first term plus n minus 1, so 8 lots of D. So we need to work out negative 6 plus 8 lots of 7. 8 sevens are 56. Take away the 6. Job done. Number 23. They do love these awkward completing the square questions. So here we go. I always like to bring the x squareds to the front, but at the same time, I'll take the minus 2 out. So minus 2 times positive x squared and minus 2 times positive 6x gives me the negative 12x. The plus 7, just ignore, just leave it on the end. We now complete the square inside the square brackets, halve the number next to x, square it and take it away. Don't forget about the 7. Expand the square brackets, so we've now got negative 2, lots of the complete of the square bit. We've got negative 2 times negative 9, positive 18, and everything now needs tidying up. They want the number at the front, so we give them it 25, and they want the brackets and stuff later, so we give them it negative 2 lots of x plus 3 squared. Number 24. Do not get put off by these. If you don't like them, you can still get a couple of marks. Try and find some gradients. One in particular, flip it and change the sign. You never know your luck. You might just blag a couple of marks. But if you do like these, here's how we go about them. So L1, I'll save a bit of room because I use quite a lot of working out on my worked answers. Rearranging this, we'd rather have y equals, because if it's in the form of y equals mx plus c, it means you've got 2 important bits of information. C, the intercept if you need it, but more likely it's the gradient you're after. So we take 5x away from both sides and we divide by 10. And we've got plus 0.8 on the end. In other words, for L1, the gradient is negative a half. It says L2 is perpendicular. Stop. L2 means the gradient, and it depends on how your teachers phrased it. They multiply together to give -1. You do negative reciprocal, or I always just stick with the simple stuff. Change the sign, flip it. So the gradient of L2 is 2. Well, we also know it passes through 8, 6. So let's apply y equals mx plus c. So the y coordinate equals the gradient times the x coordinate plus c. 6 take away 16. The equation of L2 is 2x minus 10. Now we read on. L2 crosses the x-axis. Another name for the x-axis is y equals 0. Let's stick it in. If y equals 0, we can work out x. X is 5. So that is where point A is. Point A is the coordinate 5, 0. L2 intersects the straight line with equation x equals minus 3. We've got an equation. Let's stick in x equals minus 3. Y will equal negative 2 3's, minus 6 in other words, minus 16, minus 16, you dafty, minus 10, I'm jumping ahead as you can probably tell, minus 16. Find the area of the triangle. Let's just do a little diagram. Doesn't have to be anything to scale. O is the origin. A is the coordinate 5 to the right. The coordinate of B is negative 3, 16. In other words, left a bit, down a bit. There's the triangle. And as complicated as this question's been, it's a triangle where we know the length of the base and we know its height. The height of this triangle will simply be the y coordinates. Did I say negative 16? Do apologise. So you've got a triangle where the base is 5, the height is 16. We do a half base times height. We get 40 centimetres square. Well, it's on a grid in it, so 40 square units, whatever them units may well be. And finally, number 25. N is a multiple of 5. Got it. A and B are them. Prove using algebra. So, let's do a squared then, shall we? A squared will be n plus 1 squared minus b squared will be n minus 1 all squared. Let's times everything out and see what happens. Square the first, should be big N. Square the first, square the last, times them together and double it. Same thing here, but be careful of the minus. Square the first is n squared, but it's a minus. Square the last is positive 1, but it's a minus. Time the two together and double it is negative 2n, but it's a positive, because in other words, it's a minus times a minus. The n squareds cancel. The 1's cancel. Hey, we're left with 4n. N is a multiple of 5. In other words, whatever x is, as long as x is an integer, if x is an integer, a squared minus b squared will indeed be a multiple of 20. So there's all your algebra. That is cast iron, but I would put something like hence is always a multiple of 20, and that'll do. It's only 3 marks. Don't overcomplicate. So number 25 wasn't the hardest on that paper. There were some doozies just before it, but quite a lot of bog standard stuff at the start. So don't let your opinion get swayed by 2 or 3 rough ones towards the end. Overall, not a bad paper. certainly well worth covering for revision. Some good stuff there. Anyway, I hope that walk through with work solutions, whatever you want to call it, helped. I'll see you on the next one.